Okay, you've used quadratic formula to find the two solutions. And you know those solutions are really the x-intercepts. They're here and here. That's the plus and minus part of the quadratic formula. But these numbers, these solutions were kind of normal looking numbers. Maybe they were fractions. Maybe this was like negative 3/5. Maybe this is 4/5. I don't know. But they're at the most complicated ones you got were fractions. But the solution to this quadratic, and this side is already set to 0 for us, so this quadratic is what we're going to trying to find the solutions for. Look at what it looks like when what the two solutions or the x-intercepts, what they look like. Let's go to Desmos. Here it is. Instead of k, I put x because Desmos doesn't recognize what k means. But, it makes a parabola like you would expect. But look at the x-intercepts. Look at this number. Negative 1.78078, and the decimals actually keep going much more than that. Negative 0.2807. It's just weird, right? It's just strange looking. Those are called irrational numbers. Okay? By the way, let's look at negative b over 2a and make sure it splits down the middle. Our b is 3, so negative b is negative 3 over 2 times a, and a is 2, so it's really 4, right? If I make an axis of symmetry by saying x equals, look at that line. It's perfect. This is our negative b over 2a, and it splits down the middle, okay? The quadratic formula says if I go minus something, I'm going to hit this point right here, that strange irrational solution. If I go plus square root of b squared minus 4ac, I'm going to go to this number, which is a strange irrational number. But what you're going to be asked to do in Delta Math is to show that number, not as with all the decimals, but in simplest form. Because if you do all the decimals, you're just don't have enough room to write infinite number of decimals. It keeps going forever. So you have to cut it off somewhere, and that's not exactly the answer. Okay. The simplest answer is you'll see what it looks like. Okay. So I think it's always a good idea to say what A is and B is and C is. So A is 2, B is 3, C is negative 1. Okay, and here's the quadratic formula. Remember, it's negative b over 2a. You're used to that. Plus or minus the discriminant under the square root sign. Okay, so let's fill in our a, b, and c. Our b is 3, so we're going to say negative 3, plus or minus, and then 3 squared is 9, minus 4 times a, which is 2, and c, which is negative 1, all over 2 times 2, which is 4. Okay? The denominator goes under the whole thing, but this is the complicated part right here, right? So let's focus on this. Let's even just do the discriminant first. Okay, what is this? 9, and hey, look, I have a negative and another negative in my 4ac. 2 negatives, and all this stuff is being multiplied. 2 negatives make a positive. So I might as well say 9 positive, multiply 4 times 2 times 1, and we get 8. Okay, So this is that part of it. When I add 9 and 8, we get 17. So 17 under the radical. That is our answer. Sorry, it's negative b, so I should have put a negative here. So this is our answer. Now, this is what you're going to put, and it gives you a plus minus symbol, so you can do that symbol, and a square root symbol, so you can do the square root, all over 4. But you know what? Just for fun, let's calculate this and see if these two numbers equal this number, the negative 1.78, blah, 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 and the 0.28. Let's just do one of them. Oh, they disappeared. But I remember what it was. It was -3, -3. And I'm going to do the minus part first. Minus square root 17, all divided by 4. Look over here. Negative 1.78077, blah, blah. And the decimals keep going forever. So look at this number right here. That's the same number. That's the same number. Just round it off.